Hello, welcome to my channel Math with Nazia. In this video, we are going to learn about square and square roots. So square and square roots, there is a strong relationship between square and square roots as each of them is inverse of each other. So for example, we have 3 squares. 3 square is nothing but 9. But square root of 9 is 3. So they have an inverse relationship. So let's see another example. Suppose we have 7 square. 7 square is 49. So square root of 49 is 7. So as you could see, there is an inverse relationship in this. So to find square roots, there are 2 methods to find square roots. We can either find by a prime factorization method or a long division method. So first let's see the prime factorization method. So now let's do the prime factorization method. So let's take the first example. Find the square root of 256. Whenever we have a number like this, we can use the prime factorization method. So for prime factorization method, this is the same as we did for LCM and HCF. It's the same method. So 256. So 256 is divided by 2. So this becomes 128. 128 can be further divided by 2. 64. 64 can be further divided by 2. So this becomes 32. 32 can be further divided by 2. So this becomes 16. And 16 can also be further divided into 2. So it becomes 8. 8 can also be further divided by 2. It becomes 4. When 4 also is further divided by 2, it becomes 2. And we can further finish this as 2 times 1. So this is the way we do the prime factorization method. So now square root of 256 equals square root of how many 2's we have? 1, 2, 3, 4, 5, 6, 7, 8 2's we have. So 1, 2, 3, 4, 5, 6, 7 and 8. So inside the square root I have written all the 8 2's. So now for every 2 2's we will take 1 2 outside, and for the next other 2 2 I'm going to take another 2 outside. For another 2 I'm going to take another 2. So like that I've taken out 4 2's because 2 2's are 4. So square root of 4 is 2. So like that I've grouped it. So now square root of 256 equals 2 times 2 times 2 times 2, which is 16. So isn't it very easy to find out in this method? So let's see another example. So now our second example is find the square root of 729. So we have the number 729. So let's find the square root of this. $729. So this is not divisible by 2 because it's not an even number. So let's see whether it is divisible by 3. I think you all know the divisibility test of 3. Yes, the divisibility test of 3 is you have to sum up the digits. So 7 plus 2 is 9. 9 plus 9 is 18. Yes, so this is divisible by 3. So I think you remember this divisibility test. I've already explained in my previous video. You can refer that and the link will be in the description. So now since this is divisible by 3, it is divisible 243 times. So now this will further be divisible by 3 because 2 plus 4 is 6, 6 plus 3 is 9. It's further divisible, so we get 81. We can further divide this with 3. So we get 27. So if we further divide this with 3, we get 9. And for further division of 9 with 3, we get a 3 here, and still this can be further divided as 3, 1. So now we have found the square root of 729. So square root of 729 equals square root of, how many 3's are there? 1, 2, 3, 4, 5, 6. So we have 6 3's, 3 times 3 times 3 times 3 times 3 times 3. So I've written 6 3's. So as we did for the previous thing, instead of 2 3's, I'll take 1 3 outside. Then instead of another 2 3's, I'll take another 3 outside. So another 3. So 3 times 3 times 3. So we have 3 3's here. So which is 27. So the square root of 729 is 27. Isn't it easy? So let's see another bigger number using prime factorization method. So the third example is 7,225. So we have to find a square root of a bigger number. So let's see how to find the square root of 7,225. So let me write that number here. So 7,225. As you could see, the last number is 5. So we can easily tell that this number is divisible by 5. So this I have already taught you in the divisibility rule. You can refer that video for the divisibility test. So now 5 divided by 7,225. This becomes 1, 4, and then again 4, and then this is a 5. So we have got 1,445, and I'll further divide this again by 5 since the last number is 5. This becomes 2, 8, and 9. So when I further divide this, this will be divisible by 17. 17 times 17 is 289. So this will be further divisible by 17. So 1. So now we have got the square root of 7,225, which is equal to square root of 5 times 5 times 17 times 17. So see, here we have two different numbers. So for this also we will do the same thing. We will take, instead of 2 5's, we will take 1 5 outside, and instead of 2 17's, I'll take 1 17 outside. So 17 times 5. 17 times 5 is 85. The square root of 7,225 is 85. Isn't it easy to find the square root by prime factorization method? So if you have any queries regarding this topic, you can comment down in the comment section, and for more tips and tricks, do like and subscribe to my channel. So first, let's see the first question for today, which is square root of 80 divided by square root of 405. So when this type of questions are given, now 80 is not a square number, and even 405 is not a square number. So what can be done when we don't have a square number? So when we don't have a square number, instead of taking it into its square roots, the easier way to do is, let's take the square root out and let's write 80 by 405. Let's put this number inside the square root. So now 80 and 405 both are divisible in, right, both are divisible in 5 times table. So 80 would become 16 and 405 would become 81. Now 16 and 81 are square numbers. So now what we have got is square root of 16 divided by 81. So now since both are square numbers, let's separate the square root again. So square root 16 divided by square root 81. So now you know the square root of 16. So the square root of 16 is 4. And the square root of 81 is 9. Isn't it easy to solve in this method? Whenever you have a question like this, make it into a bigger square root. First check whether these two are divisible in any common number. So when these two numbers are divisible in same number, you can take the square root outside, cross it out, and then simplify it. Isn't it easy? Now let's see the second example for today. So our second example is square root of 1,587 divided by square root of 1728. And now again the same thing, both are not the square numbers. We are going to repeat the same steps. I'll take the square root outside, and we have a number 1587, that is 1587 divided by 1728. Now let's see in which table are these two divisible in. So these two are not even numbers. The numerator is not an even number, so not divisible by 2. Divisibility test of 3. I think you all remember the divisibility test of 3. I have already explained in my previous video. I'll put the link in the description. You can refer that. So the divisibility test of 3 is you have to add up the digits and see whether it is divisible by 3 or not. So when we add up, these two are divisible by 3. So 1587, when it is divided by 3, we get it as 529, and 1728 divided by 3, we get it as 576. So now when we see 529 and 576 are square numbers, so we will again separate them. So let's separate the square root. Square root of 529 divided by square root of 576. So now 529, the square root of 529 is, right, 23. So 23 times 23 is 529, and 576 is again a square number. 24 times 24 is a square root of 576. Isn't it easy? So it can't be further simplified because 23 is a prime number, so we will leave it as such. So now let's see another example. So the third example for today is, so both two examples we did in division. Now let's do some example in multiplication. When we have square root of 72 times square root of 338. Now as we know, these two are not square numbers, so let's take them separately and find the square root of each number. So I hope you all remember the prime factorization of finding the square root. If you want to refer, you can refer my previous video. The link will be in the description below. So first let's find the square root of 72. So 72 is divisible in 2 table. 72 is divisible in 2 table. So it is 36. 36 is again divisible in 2 table. So 36 divided by 2, it would be, right, 18. 18 is again divisible by 2. So it is 2. 2 times 9. 9 is not divisible in 2. But 9 is divisible in 3. So 3 times 3, again 3 is divisible in 3. So we have got the square root of 72. Square root of 72 equals square root of 2 times, how many 2's are there? There are 3 2's and 2 3's. Right? So we have got this. So as we all know, instead of 2 2's we will take 1 2 outside, and instead of 2 3's I'll take 1 3 outside. And what is remaining? We have a square root of 2 remaining here, so we will leave that as such. So 2 times 3 is 6. 6 root 2. So square root of 72 can be written as 6 root 2. So now let's find it for 338. So the same way I'll be doing it for 338 also. As 338 is a even number, 338 will be divisible by 2. So when it is divisible by 2, it is 169. Now 169, in which table it is divisible? It is not divisible in 2, not by 3, but yeah, 169 is a, right, it is a square number. So 13 times 13 is 169. Pretty easy, right? Again 13 again can be further divisible. You can again divide it by 13. So 1. Now square root of 338 can be written as square root of 2 times 13 times 13. So instead of 2 13s, I will take 1 13 outside. So we have got 13 root 2. Root 338 can be written as 13 root 2. So now since we have a multiplication sign, root 72 times root 338, we can write this as 6 root 2 times 13 root 2. So now this whole numbers can be multiplied separately, and then root 2 and root 2. So 13 times 6. So 6 times 13 times root 2 times root 2 can be written as 2. So 6 times 13 times 2 can be written as 156. Isn't it easy? So we will find the square root by prime factorization method, simplify it, and then we will get the answer. If you have any queries regarding these type of questions, you can comment down in the comment section, and for more tips and tricks, do like and subscribe to my channel. So now let's learn how to find it in division method. So let's take the first example for today, which is that is 58,564. So this is our question, and we have to find the square root of this. So how do we find a square root of this? Using a division method. So while doing a division method, we will divide this using the regular division method. We will draw the line. We will write 5, 8, 5, 6, 4. So this is the way we write it. And then whenever we find a square root in division method, from the back side or from the right side, we take two digits in pair. So this is a pair, this is a pair. We take a pair of numbers, and the last remaining digit can be as a one digit number. So now we have 5. So 5 is not a square number. So let's see what's a square number before 5. So 2 square we have as 4. So 4 is a next square number. So since 4 is a square number, I write a 2 here, I write a 2 here. So 2 times 2 is 4. 4 will be written here. Then we have to subtract these two numbers. That is 5 minus 4, which is 1. And then the next step, usually in the regular division, we bring down one number. Here we will be bringing down both the numbers together. Now we have 185. This is done here. Now here what we do is we add this number and this number. So 2 plus 2, this becomes 4. So now we have to put one number here and here the same number. So we can either write 42 times 2, 43 times 3. So here I am going to put it as 44 times 4. So 4. So 44 times 4. 44 times 4 is 176. So we have to remember whatever number we are going to write here, the same number we will be writing there. So now we have to subtract these two numbers. So when we subtract 185 and 176, we get 9. So the difference of 185 and 176 is 9. Now as we did the previous one, we are going to bring down the next two numbers, that is 6 and 4. So I'll bring down 6 and 4 here. So now we have 964. So here we added 2, here we add the 4 here. The last digit will be added. So 44 plus 4, which is 48. Now let's think one number to be added here and the same number will be here. So that you multiply, you get 964. So when you put a 2 here and put a 2 here, we get 964. Then again when we have to subtract these two numbers. So when we subtract these two numbers, we get a 0. So now we can say the square root of 58,564 is 242. So this is a little tricky one. You just need to remember it step by step. So first we take the square number. Each step has to be done the same way, exactly what has been told. So let's see another example for a detailed understanding. So second example is question number 2. We have to find the square root of 12,544. So we have to find the square root of this. So now again we are going to use the division method. So let's start writing the numbers. 1, 2, 5, 4, 4. So again we will split it from the right side, two numbers, pair of numbers. Now here we have 1 in the starting. So 1 is a square number, it is divisible by 1. So 1 times 1 is 1. And now let's subtract 1 minus 1. We get 0. So I'll not write that 0, or if you write also it's fine. Then we bring down the other two digits here. So which is 25. Now the same thing, I'm going to add 1 plus 1, which is 2. So 2 times what would be written here? We can't write 2. If I write 22 times 2, 22 times 2 would become 44, but I want only 25. So I'll write here 1, and here also I'll write 1. So 21 times 1 will become 21. Now 25 minus 21 will become 4. Now I'm going to subtract these two, so this is 4. Now I'm going to bring down the other two 4s which are above, so now we have 444. So now again I will be adding 1 here because there was a 1 there. So this becomes 22. So 22, what number should I put here and here? Right, we will put 2. So I'll put a 2 here. Hello, welcome to my channel Math with Nazia. In this video, we are going to learn how to find a square root of a decimal number using division method. I have already explained how to find a square root by prime factorization and division method in my previous video. You can refer that. Now we are going to find the square root of a decimal number. So our first example for today is 0.0059049. So we have like this number. Usually all the students would think such a big number and how to find the square root of this, but this is very easy. So let's start doing it. As our regular division method, as we did the whole number division of a square for square roots, we are going to do the same method, but this is with decimals. So 0.0059049. So what was our first step? From the right hand side, we are going to pair the numbers. We are going to take two numbers. So this will be one pair, and this will be one pair, and this will be. So now we have paired the numbers. So before decimal there is a 0. So we will put a 0 point. And after that again we have a pair of zeros. So we will put a 0. And then now we have 0.5. 0.5 we can take it as 5. So the square number before 5 is 2. So let me take it as 2. 2 times 2 is 4. So you have to write 4 below 5. And then let's subtract these two. So when you subtract these two, 5 minus 4 is 1. Then what is the next step? Yes, we bring down the next two digits. So usually in square root we bring down 2 digits at one time. Then after bringing down 2 digits, our next step is add 2 with this, because we have here 2, and 2 plus 2 will become 4. So now we have to put one number here and a similar number here. So we can put a 4 here and we will put a 4 here. Always remember, we will put the same numbers in the ones place and in the quotient. So 44 times 4 is 176. So now let's subtract 190 with 176. So 190 minus 176 is 14. And as usual, now after that I'm going to repeat the same steps. I'm going to bring down the other two digits, which is 49. Then the next step is, since we had put 4 here, we have a 4 here, we will add 4 here. So this is 48. And now what number would come nearby 8, and the same number should be in the quotient place also. So here let's put 3, and here also we will put 3. So 483 times 3 is 1449. So now let's subtract this. We get our answer as 0. So the square root of, sorry, I forgot to put a square root. So square root of 0.0059049 equals 0.0243. Isn't it easy? As we did in the whole numbers, how did we find the square root of that? In division method, the same method we are going to use, but there is a decimal here. That's the only difference. So now let's see our second example for today. So our second example is little different. Earlier we had 0 point. So now we will take the square root of 150.0625. So I have taken two different types of examples so that you have a clear idea of how to do the division of square roots. So this is also the same way we are going to do. We will write 150.0625. I am writing the numbers little apart so that it is easy for us to pair them. So as usual, we will start from the right side. We will pair it. The decimal, before the decimal will be paired separately, and after the decimal will be paired separately. So we will start from here. These two are in two pairs, and here after the decimal, again we will start from the right side. So these two numbers will be paired and one will be separate. So as usual, we will start doing the question. 1 is a square number. 1 times 1 is 1. We will subtract 1 and 1. So we get 0 here. So it's not necessary to write a 0 here. It's understood. I will directly bring down 5 and 0. That is, I'm going to bring down 50. Now as usual, I'm going to add again 1. So this is 1 plus 1 is 2. So 2 and what number here, and the same number should be written here. So if it is 22 times 2, whatever in the ones place we write the same number in the quotient. So 22 times 2 is 44. Now let's subtract 50 and 44. So 50 minus 44 is 6. Now since there is a decimal, I'll put a decimal here, and then I'll bring down the other two digits as usual, 0, 6. The same thing again, I will add 2 here. Whatever number is in the ones place, you will add it up again. So we get a 24 here, and now we have to put one number so that we get 606 or somewhat before 606. So let me put a 2 here, and whatever number I'm going to put it in the ones place, I'll also repeat it in the quotient place. So 242 times 2. So 242 times 2 is 484. Now let's subtract this. We get, so 606 minus 484 is 122. So we have got this number, and now let's bring down the other two digits, that is 25. So now we have 12,225 here. Now the same thing, let us repeat it here. I'm just going to add the 2 and bring that down. I'll add a 2 here because 2 is in the ones place, 244. So now we have 244, and which number should I write here? The same number I should write here also. So let me write 5 and 5. So 2445 multiplied by 5 is 1225. Now let's subtract this and we get a 0 here. So the square root of 150.0625 is equal to 12.25. Isn't it easy? We have to repeat the same steps again. So this is a very easy. If you work out few questions, it will be easier for you to solve. And if you have any queries regarding these type of questions, you can comment down in the comment section. And for more tips and tricks, do like and subscribe to my channel. So now this becomes 444. So now when we subtract these two, this is 0. So the square root of 12,544 is 112. Isn't it easy? You just need to remember the two steps which we have done, and we'll get our square root easily. You can also do the prime factorization method which I taught you in my previous video, or you can use this long division method, whichever is convenient for you. So if you have any queries regarding this type of questions, do comment down in the comment section, and for more tips and tricks, do like and subscribe to my channel. Thank you. So the first question here is, the area of a square field is 60,025 meters square. Aman cycles along its boundary at 18 km per hour. In how much time will he return at the starting point? So these type of questions are usually asked for grade 9 and 10. So now whenever you have a word problem, try to split it into parts and understand first what is given and what is asked. So the first part, what is given is the area of the square field is 60,025 meters square. So we know the area here. So the area is 60,025 meters square. So this is the first part which is given to us. Now Aman cycles along its boundary. So usually boundary in the sense it is perimeter. So he cycles along the boundary at 18 km per hour. So here the speed of his cycling is given. So let's see the speed. So let's write first what is given. So speed is 18 km per hour. So these two are given to us. Now what is asked? In how much time will he return at the starting point? So first they are asking us to find out what time he will return at the starting point. So now first let's see the first part which is given to us is area. So the area of a square is side times side. Now we know the area is 60,025 equals side square. So S equals square root of 60,025. So the square root of 60,025 is 245. I am not doing the square root method again because I've already taught in my previous videos. It is very easy. Either you can do with the division method or the prime factorization method. I have already taught you this. You can refer my video. The link will be in the description. So now we have found the side. So let me write the unit also. It is meter. So the side is 245 meters. So now we have got the side. And now what is given to us next? The next one which is given to us is speed. Speed is given in 18 km per hour. So speed is in kilometer per hour, but area is in meter square. So we have to have the same units. So it is better to convert a larger unit to a smaller unit, because converting a smaller to a larger will take it into decimal. So better we convert a larger unit to a smaller unit. So converting a kilometer to meter. So now what is given? 18 km per hour. So whenever this type is given, we will write 18 and 1 kilometer equals how many meters? Yes, 1 kilometer equals 1000 meters. So I'll write 1000 here, divided by, since this is an hour, so hour we have to convert it into seconds, not to minutes. If it was minutes, we will write 160. And since it is a hour, I'm multiplying it with another 60. For 1 hour, I'm converting it into seconds. So 60 times 60. Or else you can directly write 3600. So instead of that, for you to understand, I have written 60 times 60. So now we can simplify. Whenever we have a 0 at the end, you can cross out the zeros, which is a very easy method. So that now you have got 18 times 10 divided by 6. So 18 times 10 is 180 divided by 6 times 6. You can further simplify this by crossing out, and then your speed would be 5 meter per second. So isn't it easy to find a kilometer to a meter? We have found out how much was his speed for meter per second. So now we have the side is 245 meters and the speed is 5 meter per second. So now both are in the same unit, right? Now the question is, how much time will it take to return to the starting point? So he's traveling around the boundary, right? So for that boundary is always the perimeter. So what is the perimeter of a square? Right, it's 4 times S. we don't know what is the perimeter, we know what is the side. So it is 4 times 245. So the perimeter which we have got is 980 meters. So now we have got the perimeter with which he was traveling around. So he has to travel 980 meters. So now let's find the time taken. So what is the formula to find the time taken? Correct. It is distance, total distance divided by speed. So what is our distance? 980 divided by 5. So 980 divided by 5 will get us 196 seconds. So since it is 196 seconds, we can convert it into minutes and seconds. So this will be 3 minutes and 16 seconds. So the answer, time taken for the cyclist to cycle around the boundary and come back to the starting point, is 3 minutes and 16 seconds. Isn't it easy? Pause. Isn't it easy? We are first seeing what is given to us, converting it to a perimeter, then the time taken. So now let's see the second example for today, which is, so the second example, the second word problem which we have taken for today is the greatest 4-digit number which is a perfect square. So now we have to form a greatest 4-digit number which is a perfect square. So as usual, which you know, what is the greatest 4-digit number? So the greatest 4-digit number which we all know is 9,999. So we know that the greatest number is 9,999. But the question is, which is a perfect square? So let's do the division method of finding the square root, and let's see what is the remainder. And that remainder we can subtract with this number so that we get our perfect square. So now let's do the division method. I think you all remember this method. We have already done this in our previous video. You can refer that, and the link will be given in the description below. So now let's do this question. 9,999. So what is the first step we do? Right, we pair it. We pair the numbers from the right side. So I'm just pairing it. Now we have a 99. We always write the numbers in square. So the highest square is 9 times 9, which is 81. So now we have got 9 times 9 is 81. Now let's subtract these two. So when we subtract these two, 99 minus 81, which is 18. Now the next step is to bring down these two numbers. When you bring down these two, 9 becomes 1,899. And then the next step is we add a 9 with this. So this becomes an 18. So 18, and what number should be written in the ones place? The same number should be written in the quotient. So let me take a 9 here, and here also a 9. So this becomes 1701. Now again we have to subtract. We will follow the same method. So when we subtract these two, we get 198. So since the remainder is 198, we have to subtract the remainder with 9,999. So 9,999 minus 198, which will give us 9,801. So 9,801 is the greatest square number, right? So this is our greatest square number. This can be asked in different forms. Greatest 4-digit number, 5-digit, 6-digit, anything can be asked. So whenever this type of question comes, you can find out, take a greatest number and then find out the square root, and then whatever the remainder is there, subtract it so that you get the greatest 4-digit number. Right, now let's see the third example for today. So our third example for today is the product of two number is 1296. If one number is 16 times the other, find the number. So first we have to find the product of two numbers. So let the two numbers be, what is the two numbers? Let's keep it as A and B. So let me take the two numbers as A and B. So we have to find the product of two numbers. So what has been asked? A times B, which is equal to 1296. So this is what is given in our first point. So as I told you, always split the question, understand part by part, and then substitute it and then find the answer. So we have done the first part. The product of two numbers is 1296. So let the two numbers be A and B. And the product of them is A times B equals 1296. Clear? Now let's see the second part. If one number is 16 times the other. So A equals 16 times B. And B equals B. I'll keep the A as 16. You can take it in either way. You can keep A as A and take B as 16 times A. Any way you can do it. So I have taken A as 16 times B and B as B itself. So now since we know the value of A is 16B and B is B, let's substitute here. So A is 16B times B equals 1296. Now 16B times B is 16B square, which is equal 1296. B square equals 1296 divided by 16. So B square will be equal to 81. So since B square is equal to 81, B equals square root of 81. And 81 is a square number, so we can directly write the value of B is 9. So now we have got the value of B. Now what is A? A is 16B. So we know what is A is 16B. So A equals 16 times 9. So A equals 144. Isn't it easy? We have found out what is A and what is B. So if you want to verify whether your answer is right or wrong. So for these type of questions, you can verify whether your answer is right or wrong. So whenever you want to verify to check if your answer, what you have got is right or wrong, you can just multiply A times B. So that will be 9 times 144. So here I'm just writing a small verification so that it is easy for you to understand. So whenever you want to verify, since these two numbers we have got, A times B equals 1296. So let's find out whether 144 times 9 is 1296. So 144 times 9, whenever we multiply, we get 1296. So this is, so now since we have verified, it will be easy for us to know whether we have done it right or wrong. So 144 times 9 is 1296. So isn't it easy? We can easily verify. This is just a verification. If you don't want to do, you can skip this. It is just for your verification to understand whether you have done your answer right or wrong. So if you have any queries related to word problems, you can comment down in the comment section. And for more tips and tricks, do like and subscribe to my channel. I have already taught how to find square root for a whole number and for decimal numbers in my previous video. You can refer that, and the links are given below in the description. So let's see the first example for today, which is find the least number which must be subtracted from 44,01,624. So either you can tell it as 44,01,624 in Indian system. If it is an international system, you can call it as a 4,401,624. Both are same. To make them a perfect square, so we must see which number should be subtracted from this, because this is not a perfect square. So let's see which number should be subtracted from this. So for this kind of question, we will do the division method of finding a square root. I have already taught how to find a square root using a division method in my previous video. You can refer that. The links are given below in the description. So now let's start the dividing this number. So we will use the long division method. So here we have 44 lakhs 1624. So this is the number given. So how will we do for a division of a square number? How will we find a square root? We will group the numbers first. So from the right side, two numbers, we have to pair them in groups. So here the last number is a single digit number. So now 4 is a square number. So 2 times 2. So whatever you write in here, you will write the same number here. So 2 times 2, which is 4. So then we will subtract these two. So 4 minus 4 is 0. So you write it or you don't write it, no problem. Then we bring down 2 digits. I have already explained you all this in my previous video. Please refer that. And now 2 must be added to this. So this becomes 4. And here, if you could see, it's 40 here and it is 4 here. If I'm going to put even a 1 here and a 1 here, this becomes 41, which can't be done because it's not right. So we will not use this 1 here. We will remove this 1. So since this is not divisible, we put a 0 here and as well as here. After putting a 0, then we again bring down the next 2 digits. So which is 1 and 6. Now we have 4016 and we have a 40 here. So which number you would put here in the ones place? The same number you will be putting it there. So we will be putting a 9 here and a 9 here. So 400 times 9 is 3681. Now let's subtract these two. The steps are the same steps which will be repeated again and again. So then when we subtract these two, we get 335. Then we bring down again 24 below. Then as usual, ones place will be added again with the same digit. So this becomes 418. So now which digit would be put here? Same digit should be put there also. So we'll put a 8 here and a 8 here. So this becomes 33504. 33,504. So now let's subtract this and see what we have. When we subtract these two, we get 20. So 20 is the remainder here. This is the square number. So it's very easy. Whatever is remaining, we will tell that 20 must be subtracted from 44 lakh 1624. Isn't it easy? We just take the remainder and we will tell that this number must be subtracted from this. So 20 is the answer. So isn't it easy? We will do the division method of a square root and whatever is the remainder we will subtract it. So now let's see another example. So here is the second example. Here this is somewhat similar to the previous question. Find the least number which must be added. In the previous question we had subtracted, this was added to 37,460 to make it a perfect square. So we will do the same method again. The same procedures would be done, same division, and the last remainder, instead of we wrote it in the previous thing that 20 must be subtracted, here we will write the remainder must be added. Pretty easy. So let's start solving this in the long division method. So here is it. The number is 37,460. So the first step is we will group it. We will make it into pairs. So as usual, the first number is without a pair. So this is not a square number. So 2 and 2 is not done. So we will use 1. So 1 times 1 is 1. So now let's subtract 3 and 1. So when 3 minus 1 is 2. Then as usual the same steps, we will bring down the other 2 digit, add 1 with this, so this becomes 2. And then 2, what number should we put here? The same number we'll be putting there. So it is 9 here and 9 here also. So 29 times 9, which is 261. So now 261 should be subtracted from 274. So when we subtract, we get 13 as a remainder. Then we'll bring down the next 2 digit. So 1360. Now again the same step, 9 would be added here. So this would become 38, and now again I'll put a 3 here and the same number. You could see that whatever number I'm putting here, I'll put the same number here. So now 383 times 3, which is 1149. Now when you subtract these two, we get 211. So you can directly tell it as 211 is the answer. 211 must be added to 37,460 to make it a perfect square. So isn't it easy? You could just leave with this, or you can find the next numbers which must be done. So it's better we will stop with this. 211. In the previous question we just directly subtracted the remainder, but here what we will do is, here the remainder is 211 and our quotient is 193. So we have to take, since 193 square is less than 37,000, is less than 37,460, what we have to do is we have to take 194 square. So what is 194 square? So 194 square will be 37,636. So we have to make it at this number. So we will see what is the difference between 190, this number which is given 37,460, and 37,636. So 37,636 minus 37,460. So we will subtract these two. So when we subtract these two, we get 176. So 176 must be added to, what was the number given to us? 37,460. Isn't it easy? This is a little different question. Whatever is our remainder, we will leave it as such. We will take the quotient 193. 193 square is not equal to this. So we will take the next digit, which is 194 square, and we will find what is 194 square and subtract with the given number. So when we subtract these two, we get a number. So that number must be added to the given question. Isn't it very easy? If you have any queries regarding these type of questions, please comment down in the comment section, and for more tips and tricks, do like and subscribe to my channel. So I have already explained about square roots, how to find square roots, different methods to find square roots in my previous video. You can refer that. The links will be given in the description. So the first example for today is, find the smallest number by which 12,150 must be multiplied so that the product is a perfect square. So we have to see with which number is 12,150. It should be multiplied so that it is a perfect square. So as you could see in this question, from the question we know that this is not a perfect square. So there should be some other number with this to make it a perfect square. So there should be some number to be multiplied with this, and that should be the smallest number. So first let's see this. Let's find the square root of this. So we will use the prime factorization method for this type of questions. So the first number is, the number which is given is 12150. So I'm going to divide this with 2. We'll always take the smallest number, which is 2. This is an even number, so this is divisible by 2. So this will have 6. And this is an important thing, since 1 is not divisible, I'm going to put a 0. Usually students skip this 0 and then they take it as 15. But whenever this 1 is not divisible, you have to put a 0 here. And then we will take this as 15. So it is 7. And then there will be a 1 here. So this becomes 5. So whenever you have a number which is not divisible in the between, you have to put a 0. Don't forget that. Usually everyone makes a mistake in this. Please be careful here. So now since the last number is 5, so this is divisible by 5. So when this is divisible by 5, we have 1, 2, and here it would be 1 and 5. So it is 1, 2, 1, 5. And then this will be again further divided with 5. So we get 2, 4, and 3. So this will again be divided with, this is not an even number to be divided with 2. The number doesn't end with 5 or 0 to be divided by 5. This was divisible by 3. So you can add up the digits. You have learned the divisibility rule. I have already explained you the divisibility rule. You can check on my previous video. So 2 plus 4 is 6. 6 plus 3 is 9. So this is divisible by 3. So when it is divisible by 3, it is 81. And 81 will again be divisible by 3, which is 27. 27 will be further divisible. So we have to divide some more numbers. So if it is further divisible by 3, you get 9 here, and 9 will be further divisible by 3. 3 times 3 is 9, and 3 again with 3. So this is very easy to do a prime factorization method. We will do till we get a 1 here. So when we write what is the square root of 12150, which is equal to the square root of, how many 2's we have? We have only 1 2. So I will write 1 2. We have 2 5's. So I'll write 2 5's here. Then how many 3's are there? 2, 4, 5. There are 5 3's. So let me write 1, 2, 3, 4 and 5. So I have written all the numbers which we have got at this side inside the square root. So I have already taught you, for square root we will bring 2 numbers instead of 2 same numbers, we will bring 1 number outside. So 5 times 5 will be 25. So I'll take 1 5 outside instead of 2 5's. Same way, instead of 2 3's, let me take 1 3 outside. Again, instead of 2 3's, I'll take 1 3 outside. So now, but root 2 and 3, these two doesn't have a common numbers to remove from the square root. So I'll just put it as 2 times 3. So now since 2 and 3 doesn't have a common number here, so 2 times 3, which is 6. So this number 12,150 has to be multiplied with 6. So when we multiply this with 6, 12,150 should be times by 6. So when you times by 6, we will make it into pairs. We will make these numbers into pairs. We will be having 2 times 3 times 3 times 3 times 5, and then in another group again we will be having 2 times 3 times, there will be 3 3's and 5. How did this come? I have written it from here, 2, and there are 1 2 3 4 5 3's, and then again we are again multiplying it with 6. So there are 2 3's here, and then there are 2 2's here. So I'll just group it up for your understanding. So this would become 270 times 270. So the answer is 270 the whole square. So we can directly write 6 must be multiplied with 1250 to make it a perfect square. So the next perfect square would be 270. 6 must be multiplied. So the next square number would be 270 the whole square. Isn't it easy? So we will first find the square root and see which number is remaining, and then we multiply those two numbers, which is 6. So since 6 is the remaining number, we will multiply this bigger number with the number which is given by 6 and find the square root of that. So square root of that is 270. You can either leave with this or you can find till this. Both are right. So now let's see a second example. So the second example is here. Find the smallest number by which 2904 be divided. So the resulting number is a perfect square. So first it was the previous question, it was multiplying a number. Now the main statement which is given is to divide. And now this is also should be the smallest number. So as we did the previous question, 2904, we will first find the prime factorization method. So let's start doing the question. So 2904. So since this is an even number, this will be divisible by 2. So this is 1, 4, 5 and 2. And this would be further divisible by 2. So we get 726. This will be further divisible by 2. So we would be getting 363. 363. Now this is not an even number. It will not be divisible by 2. So it is. So this is divisible by 3. So here we would be getting 121. And 121 is not divisible by 3. It is divisible by 11. 11. And again this will be divisible by 11. So 1. So now let's see, square root of 2904 will be equal to, so how many 2's are there? There are 3 2's, 1 3 and 2 11. So let me write 2 times 2 times 2 times 3 times 11 times 11. So as you know, instead of 2 2's, 1 2 would be out. Instead of 2 11's, there will be 1 11 outside. And as usual, the previous question also we got the same thing. 2 and 3 are remaining. So 2 times 3 would be 6. So now we have to divide the number which is given by 6. So 2904 would be divided by 6. So when we divide this by 6, the resultant perfect square could be an easier way to write. We will just write these 2 2's and these 2 11. We will not write the other 2 3's, and we will skip this and we will skip this because we are dividing. In the previous question we added that because we were multiplying. Now since we are dividing, we will remove this and we will only have 2 times 11 and 2 times 11. So 2 times 11 is 22 times 22. So which is a 22 square. So the next resultant square is 22 square. So isn't it easy? You will just find the prime factorization method, write the factors of that, and then take a square root, and whatever numbers are remaining inside the square root, you will multiply that, and that answer would be divided. If it is divide, you divide. If it is multiply, you multiply. So if you have any queries regarding these type of word problems, so you can comment down in the comment section. And for more tips and tricks, do like and subscribe to my channel.